Hey, hello, 102 students. Let me make a quick comment here about Chapter 5, number 46. And in this problem, they ask for what location or what configuration of the moon here, given these four quarters, would make the highest tide, or the highest high tides and the lowest low tides. All right, so a quick review here. Let's just say we have this Earth, and there's this equally distributed water on the surface. So forget the continents for a second. Let's just say you have a round ball, you put some water on it. Gravity's going to pull it equally depth all the way around. And then when you put another object nearby, whether it be the moon or the sun, so I'll just say moon / sun. I'm not trying to distinguish between the two. But what would happen is, because of the force of gravity, and so here's the universal law of gravity right here. This law says that it pulls at different strengths depending on how far away you are. So if I put like a little mark right here and called this position alpha, and the center of the Earth position beta, and I'll call this the backside of the Earth position gamma, each of these three spots are pulled with a different amount of strength from the object, either the moon or the sun. And clearly the one that's closest. So alpha would pull the most, beta would be somewhere between, and gamma the least. Okay? So what ends up happening then is this front edge, and maybe I'll just try to draw a line straight down here, because I do want you to understand that this Earth does get pulled over by a small distance. There is an attraction of the Earth towards the moon or towards the sun. But the pull of the water is actually more, so it gets pulled further. So if we're looking at this small little piece, which it looks like in my drawing, I drew it about, I can't really get a good look with my camera there, but I'm gonna say I drew it over about 7 or 8 millimeters. Then the water would get pulled more than 7 or 8. And so if we made a line straight down and only pulled the water over 7 or 8, let me go a little bit more. 7 would be right about there. 8, how about I go to, maybe I'll exaggerate to make it look really good, a 12. So the alpha gets pulled over even more. Now, if we look at the position of the water on the backside, call that gamma, it's the furthest away, and it gets pulled even less. So instead of getting pulled over, say, 7, it only gets pulled over, say, 3. And so what ends up happening is that the depth of the water from the Earth is actually deeper along a line connecting the Earth with, say, the moon or the sun. And it's deeper on both the front and the back. And of course that water comes from somewhere, so it flows around what in my picture would be the top and bottom. And so the shape of the water would be elongated. It would be more of an elliptical shape here now. And of course, you got to remember that the Earth is spinning in a 24-hour period. So if you have the water elongated because of the effect of this moon or sun, and then it spins underneath it, somebody on the surface, and maybe I'll just put a little stick figure here up on the surface. Right now, they're going to be in a location where the water level is low, so they would say this is low tide. But 6 hours later, they will have moved into this bulge here, so that would be high tide for them. 6 hours later, they're going to be in a shallow water, if you will, so that would be low tide again, and then they would move to high tide, and then finally 6 more hours, so 1 full day later, they're back to that low tide. And it's a little more than that because now the moon has moved a little bit. But when you get back to the same relative location in line with the moon, you're going to then spin and rotate, and you're going to go through 2 low bulges, or 2 high bulges, and 2 low spots of the water. And so you're going to have 2 high tides and 2 low tides. Okay? And so that's the effect of the moon or the sun. So now the fun part of this problem is to say, okay, what if you have the 2 objects? And so the 2 objects, when they're, say, like this, so let me actually say this is the moon. And then over here in line with that, we have the sun. The sun would be doing the same effect. So they would work together. That is, you would have a bulge going in my picture here, a horizontal direction because of the moon, and then also the water would bulge this way because of the sun. And because of that, the bulge, I guess, created by the moon plus the bulge created by the sun would add together. And so you'd get really, 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 really high tides. But you would also, because you pulled the water away, got really, really low tides. So when you have your high tides is when you also have your low tides. Okay, now, if they are at a 90-degree angle to each other, maybe I got to draw it on the backside here. But if I have the Earth that at first has an equal distributed water around it, and if I put the moon here, but the sun here, the bulge from the moon is going to go kind of in a horizontal direction, but the bulge from the sun is going to go in this vertical direction, and these two are kind of fighting each other. Now, the moon wins in the sense that it makes a stronger effect on the tide than the sun, and the ultimate result then is you get a bulge horizontal, more towards the moon, but it's not as big as it would have been by the moon itself, or certainly not as big as when we had the sun helping the moon. And so because of that, this bulge is kind of small, and so somebody on the planet Earth spinning around in a 24-hour day would end up going into, say, the bulge here in 6 hours, and their high tide wouldn't really be that high. And since it didn't pull it up very high, the low tide doesn't go very low. So 6 hours later, they'd go into the low tide, and it just wouldn't be very low. And so if you look at our tide charts, when we have things like this, which is either a new moon or a full moon, you get really, really high tides and low tides. Well, we call these our spring tides. And our nep tides here is when we have them at 90 degrees. So when the moon is in the first quarter or when the moon's over here in the third quarter, you get kind of this effect. And our high tides are pretty small. In fact, it was just recently, we had some really, really good spring tides. I mean, we were looking at, these was pushing 8 feet above sea level, and this was actually getting just under sea level. It was like negative ½ foot. And I think that was about a week ago. So we're probably more in this category. I haven't really paid much attention to the phases on the moon recently. So don't really know where we are, but I think we're more in this category. And so our high tides are going to be like 4 feet, and our low tides are still going to be 2 feet above sea level. So there's only going to be a change of about 2 feet. Anyways, so anytime they're in a line. Now, I know back here I drew them on the same side, but because the bulge goes in each direction, as long as they're in a line, so if the moon's over here, you'd get that same effect. So when the moon's over here on the right, that would be a new moon, And then when it's over here, that'd be a full moon. And so that would be positions D and B in the picture. But D and B would each make a really, really high tide and a corresponding low tide. So that would be the answer to this question. Whereas the first and third quarter, which would be represented by A and C, would be, well, it would not be the answer. Oh, wait. My apologies. I think I read this wrong. Which position of the moon in the figure corresponds to the smallest difference between high tides? Sad. I'm sorry. Totally read that wrong. The smallest difference between them then would be the A and the C. There's not much of a change between the high tides and the low tides in this category. Okay, so let me say it again now that I had read it wrong here. Your highest high tide and lowest low tide, so a big difference, would be your B and D. That's not what they're asking. They're asking for the smallest difference between the high tides and the low tide. So that'd be the A and the C. Okay.